the magnetic field will also interact with the moving charge. Okay. If we have a charge move in the region with a magnetic field, the magnetic field will exert the force on the moving charge. Okay. The formula for the magnetic force on the moving charge is a little bit complicated. It's more complicated than the electric force on the charge. Okay, but the form is similar. We know that if we have a charge move with the velocity v like this in the region with the magnetic field point in this direction like this, and the velocity vector of the moving charge and the vector of the magnetic field has an angle theta between these two vectors. The magnetic force exerted on this charge will point perpendicular to the plane form these two vectors, like in this figure. Okay, and this is a velocity vector, and this is a vector for the magnetic field. And this plane, these two vectors align on this plane. Okay, these two vectors are on this plane, which means that this plane can form from these two vectors, and the magnetic force will point perpendicular to this plane. The formula for the magnetic force is Fb equal to the QV cross B. Okay, this is the cross product between two vectors. Okay, and from this cross product, it means that this magnetic force will perpendicular to both V and B, which is the same meaning that like the magnetic force is perpendicular to the plane that formed by these two vectors. Okay. Also, from this cross product, we know that the magnitude of the cross product of V cross B is VB sine theta, which is the angle theta between these two vectors. Okay, which means that the magnitude of FB is the magnitude of this QV cos B, which is a QVB sine theta. Okay, so this is the magnitude of the magnetic force. About the direction of the magnetic force, we use the right hand rule. Okay, as in this figure, if we have the charge moving with the velocity vector in this direction, and if you point your forefinger in the direction of the velocity vector, and the magnetic field point out from your palm like this, magnetic field point out from your palm, the right hand rule indicates that the magnetic force will point in the direction of your thumb. Okay, the magnetic field will point in the direction of your thumb. Okay, so this is a right hand rule. Oh, sorry, I skipped something. Okay, let's see. Okay, let's say like this. This is the magnetic force for the positive charge moving in this direction. Okay, this is the magnetic force of the positive charge moving in this direction. Okay, why I have to say that it is a positive charge? Because you can see that the magnetic force is Fb, which is equal to V cos B. We can write this into two parts. That is This is okay, I will write here. This is the FB which equal to Q times V cross B. Okay, this V cross B will have the direction perpendicular to the plane that form the vector V and B, and follow the right hand rule. Okay. But we have this Q in front of the V cross B. So it means that if Q is positive, like this, Q times V cross B will point in the same direction as the V cross B, right? So in this figure, it means that if we have a positive charge moving in this velocity vector in the region with the magnetic field point in this direction, from the right hand rule, we must have that this the magnetic force will point in this direction, which is the same direction of the V cross B. Okay, this is the same direction of the V cross B, because here the charge is a positive charge. Okay, but what will happen if the charge is negative charge? If we look at this figure, you can see that we have the magnetic field point in this direction, right? And we have the positive charge move upward with this velocity vector like this. And from the right hand rule, we have that V cross B will point perpendicular to both V and B and follow the right hand rule. Okay, and if you point your forefinger in this direction and your the magnetic field point out of your palm, you can see that your thumb will point in this direction, and this is the direction of V cross B. If this charge is positive, it means that QV cross B, which is FB, will point in the same direction as the V cross B. But if the charge is negative, here you can see that QV cross B will point in the opposite direction of the V cross B, right? So in this case, the magnetic force will point in this direction, in the opposite direction of the V cross B. Okay. Is a rule for the magnetic force on the moving charge.